All right, a very basic object that we could use to work on simple genetics is called a Punnett square. Punnett. Okay, a Punnett square. Let's see. I don't even need to make this tough on me. Okay, it's a square with lines. Okay, that's what a Punnett square looks like. It helps you go through and see with the dominant and recessive alleles. Let's look at Mendel's um, pea plants. Okay. Ooh, this could be tough. All right. The dominant allele is always the capital. So if we're talking about height for pea plants, let's just use D as its height marker, just so that we have something to compare it to. A capital D would be regular height. A lowercase d would be lower height or dwarf height. What Gregor did is he took a purebred tall. That means it's got purebred, means that it's got two capital D's, right? And crossed it with a purebred dwarf, which means it's got two lower D's. So you have a purebred there, purebred there. This is a top one is purebred with regular height, and this is a purebred with dwarf height. And then you just cross them. So what you do now is you take the Punnett square allows you to take it. You'll take the capital D's and take it down. So this one goes there. This one goes there. Okay. So this one goes here and here. So it's got capital D, capital D. This one goes here and here. So it's got capital D, capital D. Okay. So you've got the pure regular height plant done. So then you have to go across. You've got these lowercase d's, lower d, which is dwarf, and lower d. Right here, this one's got to go all the way across. So it's lower d and lower d. All right. So when we're looking at these things, this goes down. The top one, the one on top, goes down both squares, and this one goes across both squares, like that. So what does this tell us about this plant? Can any of these plants, well, let me see if I can just erase this. Shouldn't have done that. Can I just erase that? Nope. All right. So what would the outcome for these plants be? Right here. Right here's the offspring. Right here's the parents right over here. Parent 1, dwarf parent, purebred. Parent 2, dwarf dwarf parent. I'm sorry, regular size parent. So what would these be? Well, this would be big D, little d, big D, little d. All four of them are big D, little d. So every genotype is going to be big D, little d, right? Because that's all four of them turn out that way. What would that make this plant? Well, the big D is a regular height, which is dominant. So it masks this little d, so they would all be, all four, or however many times you wanted to do this, it's going to be a regular heighted pea plant. So this would be the genotype for this crossing. A purebred tall, a regular, and a purebred short or dwarf is going to come out. The genotype will be big D, little d. Now, what does that mean on the phenotype? The phenotype is what? How it looks, correct. So what you could see. So what would these plants be? They would all be regular height, correct. Now let's go to another one. Make me another, well, let's see if I can do it on this page. Let's make another Punnett square. So I guess I should have left more room. All right, so now we take two of these offspring. Let's take this one and this one, okay? And we take these and we're going to cross them. So we have a big D, little d in the genotype, which is a regular sized plant, but its genotype is big D, little d. And then we'll take this one over here, which is a regular sized plant because of the dominant regular size allele, big D, little d. And that's genotype. Now we cross them. You take this D down, big D, big D. Take this D across, that's little d, little d. I mean, I'm taking it down. Now you go this across. That's a big D. That's a big D. Take this one across. Little d, little d. All right, so what do we have now? We cross non-purebreds, regular sized plants. You get one purebred, right? One big D there. So you have one purebred regular sized plant. You have basically these are big D, little d's, both of them. So you have two regular sized plants that are not purebred, they're mixed. And then you have this last plant. It's a purebred little d, which is a dwarf plant. So you will have three regular sized plants and a dwarf plant. So Mendel's looking at this and he's planting all these pea plants, and he noticed he started with a pure regular sized plant, a pure dwarf plant, crossed them, and he gets all regular size. So he takes two of these offspring, cross them again. He thinks he's going to get regular size because he knows now that regular size plants are dominant over recessive plants. But when he does this, this is just the odds statistically. He has three regular size and one dwarf. And the only way you can get a dwarf is if he has little d, little d. All right, when we talk about this, we're talking about a couple of different things. We're going to talk about ratios. We talk about probability. And we talk about percentages. So ratio, what is the ratio? Oops. What is ratio? Well, ratio shows relation between two quantities. Back here in our Punnett square, what's going to be the ratio to tall plants? Right here, all four of them are tall, right? So there's a total of 4 squares, so that's always the second number. So the ratio would be, this means ratio, or 2. So the second number will be 4 because we have 4 squares, right? We have 4 possibilities. So how many tall plants to short plants? Well, there's 4 tall plants on this one, so it'll be 4 to 4. Now down here, what's the ratio to tall plants to short plants again? Remember that there's 4 possibilities, so the 4 is the second letter, or I'm sorry, second number, and we have 3 tall. So if we want to know how many tall plants are possible, it'd be 3 to 4, right? But if we want to know how many short plants there would be, the possibilities would be, it'd be 1 to 4. Do you see that? Because right here's the shorts. We have 1. Okay. So that's how ratio is. Now, probability. Probability. How probable or likelihood is it's supposed to happen? The probability is a likelihood or chance of a specific outcome in relation to the total number of possible outcomes. All right. So this would be probability. I'm sorry, probability. 3 to 4, 1 to 4, 4 to 4. All right. Percentage. The percentage. What is the percent? All right. What percent of these will be tall? 100%, right? What percent will be short? 0%. Over here, what percent? 3 out of 4. So what you do, you take 3 divided by 4, which comes up to 75, or 0.75 actually. But that would be 75%. If you want to know how many short, it'd be 1 divided by 4, or 25%. All right, so that's percentage. That's how you figure out percentages. So phenotypes are what you can see. You can see that all 4 of these would be tall. You can see that 3 out of the 4 of these would be tall and 1 would be short. That's what you can see. Phenotype is what you can see. Genotype is the actually gene that you can see. You can see these are all big D, little d, right? You can see this is big D, this was big D, little d, and this was little d, little d. So genotype, you can actually see what you're working with, whereas phenotype, you can only see, you can only count what you see, which is like if brown eyes, blonde hair, big feet, something along those lines. Now the ratio and the probabilities are about the same, so we're just going to probably go with ratios and percentages, all we're going to really listen to.